Hi friends, today we are going to discuss about 8085 pin configuration. It consists of 40 pin IC. From left side, from the top of the IC, number the value 1 to 20 and the right hand side 21 to 40. That should be in the form of U shape. It consists of 6 groups: address bus, data bus, control and status signals, power supply and frequency signals, externally initiated signals, serial I/O signals. We are going to discuss one by one. Address bus. 8085 has 16 address lines. These 16 address lines splitted into two segments, that is AD0 to AD7 and A8 to A15. The 8 address lines A8 to A15s are unidirectional and serves as a higher order address bus. AD0 to AD7 are bidirectional. These lines serves as both address and data bus. During the first part of the machine cycle, these lines are used as a lower order address bus. During the later part of the machine cycle, these lines are used as 8-bit bidirectional data bus. The lower order address bus can be separated from the bidirectional data bus by the demultiplexing operation using the latch. Next, power supply and frequency signals. Power supply signals consists of VCC and VSS. Here, plus 5 voltage supply is provided. VSS is 0 voltage, that is nothing but ground, is given in pin number 20. Next, frequency signals. The 3 pins are frequency signals X1, X2 and clock out. X1 and X2 are crystal or tuned circuit like LC or RC network is connected between these 2 pins. The internal frequency generator divides the oscillator frequency by 2. Therefore, to operate a system at 3 MHz, the crystal of the tuned circuit must have the frequency of 6 MHz. Clock out. Clock output is used as a system clock for other devices and its frequency is half of the oscillator frequency. Next, control and status signals. This group of signals includes 2 control signals, that is read bar and write bar, 3 status signals I/O or memory bar S1 and S0 to identify the nature of the operation, and 1 special signal ALE, that is address latch enable, to indicate the beginning of the operation. Address latch enable. This is a positive going pulse generator every time the 8085 begins an operation, that is machine cycle. It is used to demultiplex the multiplexed address and data bus. During the first part of the machine cycle, that is T1 time period, the ALE signal should be high and the multiplexed line AD0 to AD7 serves as a lower order address bus, that is A0 to A7. During the remaining parts, the machine cycle, that is T2, T3, T4 and all the others, the ALE signal becomes low and the demultiplexed line serves as a 8-bit data bus, that is nothing but D0 to D7. The demultiplexed operation is done by the latch as well as the ALE signal. Read bar. This is a read control active low signal. This signal indicates that the selected I/O or memory device is to be read and the data are available on the data bus. Next is write bar. This is a write control active low signal. This signal indicates that the data on the data bus are to be written into a selected memory or I/O location. Next, I/O or memory bar. This is a status signal used to differentiate between I/O and memory operations. When I/O or memory bar is equal to 1, that is high, it indicates an I/O operation. When I/O or memory bar is equal to 0, that is active low signal, it indicates a memory operation. This signal is combined with the read bar and write bar signal to generate I/O or memory control signals. Next, S0 and S1. These are the status signals and are used to identify various operations, that is the type of machine cycles. Either it is opcode fetch, memory read, memory write, I/O read or I/O write, interrupt acknowledgement, halt, hold and reset. All the types can be identified and it can be represented by using the S0 and S1. Next is externally initiated signals. This group of signals includes 5 interrupt signals, 1 interrupt acknowledgement signal, ready signal, 2 signals for DMA operation and 2 reset signals. Interrupt signals. The 8085 processor provides 5 interrupt signals that are used to interrupt a program execution. These signals are INTR, that is nothing but interrupt request, RST 7.5, RST 6.5, RST 7.5, that is restart interrupt 7.5, 6.5, 5.5, and trap, that is the non-maskable interrupt. The processor provides one acknowledged signal for the interrupt, namely INTA bar. It's the active low signal to indicate the processor has acknowledged an interrupt. Next is ready signal. This is an active input signal to the microprocessor. It is used to sense whether a peripheral is ready or not for the data transfer. When the signal goes slow, the processor waits for a number of clock cycles until it goes slow. That is, it is used to synchronize low peripheral to the processor. Next is DMA signals, direct memory access. It has 2 signals, hold and HLDA. Hold. It is a DMA request signal. This input signal indicates that a peripheral is requesting the use of the address and data buses for the DMA operation. HLDA, hold acknowledge. It is a DMA acknowledge signal. This active high output signal acknowledges the hold request. Reset signals. 2 pins are allotted for the reset operation. That is reset in bar. It is an active low input signal. Whenever the program counter is set to 0, the buses are tri-stated, interrupt enables and HLDA flip-flops are reset, content of the initial or internal buses are affected randomly at the time it should be in low condition. Reset out. This is an active high output signal. This signal indicates that the processor is being reset and it is used to reset the other devices connected to the processor. Sixth group is serial I/O signals. 2 signals are allotted for the serial I/O operation, that is SOD and SID. SOD, serial output data. This line is used for serial transmission. The data bits are sent over this single line, 1 bit at a time. That is the transmission over telephone lines. SID or serial input data. This line is used for serial reception. This data bits are sent from the external devices to the processor through a single line or by single bits. Thank you, friends.